Hello, I'm Tom Janicki with the Propane Education and Research Council out of Washington, D.C. I'm here today to talk about propane gas systems considerations for commercial construction. Propane can bring all the advantages of gas to commercial buildings at a cost-effective price due to the strong and accessible refueling infrastructure established across the U.S. Domestic propane supply and consumption has encouraged innovations in tank manufacturing and distribution networks that make it ideal for commercial use in energy needs. Now propane can be used as a commercial energy source for any commercial building that does not have easy and affordable access to natural gas. It provides fuel for energy-efficient gas space heating, water heating, cooking, fireplaces, clothes drying, and a variety of other building needs. Today, propane is becoming a popular fuel choice for high-performance commercial buildings because it reduces operating costs, it's clean, versatile, and most importantly, safe. It's being used for new commercial construction, upgrades, and major renovations, as well as efficiency upgrades and retrofits. Although propane accounts for less than 2% of all energy used in the United States, it has some very important uses. Propane has 6 main applications inside a commercial building: space heating, water heating, cooking, clothes drying, fireplaces, and dehumidification. Propane also has many uses outside a commercial building, including standby generators, patio amenities, and snow melt systems. Today, more than 10 million propane vehicles are used around the world. Propane vehicles can achieve cost savings of up to 40% over gasoline vehicles. These savings are partially due to less maintenance and federal and state tax credits. Propane fuel delivers high-octane power, but is a low-carbon alternative that produces significantly fewer greenhouse gas emissions than diesel and gasoline. The EPA has also concluded that propane-fueled vehicles produce 30 to 90% less carbon monoxide and about 50% fewer toxins and other smog-producing emissions in gasoline engines. On commercial projects, refueling stations can be integrated into central propane gas systems and provide services for a large variety of commercial vehicle fleets. Typical commercial vehicles include municipal and law enforcement vehicles and taxi fleets, school buses, transport shuttles, golf carts, commercial mowers and lawn care equipment, forklifts, and construction vehicles. Propane is also a useful energy source during construction. On the job site, propane is used for temporary construction heating needs, portable generators, and other equipment. In commercial construction, propane is used much like natural gas. The most important difference is that propane is delivered on a regular basis via a bobtail delivery truck or highway transport vehicle and stored on site in tanks. There are 3 primary components to a commercial building's propane system: the distribution system and optional components. In this module, we'll take a closer look at these components and identify design criteria that will aid successful implementation of propane on a commercial project. Tank ranges from small 125-gallon tanks up to spot energy needs for a 120,000-gallon tank or larger storage tanks. Propane tanks are made of high-strength carbon steel and designed and constructed to ASME Section 8, Division 1, and NPGA 58 liquefied petroleum gas code for stationary use vehicles. Propane tanks can provide on-site storage for commercial building products of any size, from the smallest commercial building to a sprawling resort or retail complex. Propane storage can be located either underground or above ground. Above ground storage can be vertical or horizontal and typically installed in low visibility areas. They can be fenced or heavily landscaped to enhance security, safety, and aesthetics. They're typically lifted into place and supported by saddles or bed plates and placed on concrete piers if installed above ground. On a commercial project, underground propane storage tanks are a great solution when real estate is limited, required for parking, or above ground storage is prohibitive. They also provide added safety in the unlikely event of a fire or other natural hazard. In jurisdictions where heating oil is banned for underground use, this gives propane a major competitive energy advantage. To resist damage from impact or abrasion, underground tanks are typically coated with a protective coating of highly solid polyurethane, and underground tanks can be buried with minimal excavation cost, leaving only small domes visible just inches above the ground. They're sometimes enclosed by concrete bunkers to ensure proper placement and to prevent settling. On commercial projects, a propane installer will typically determine the placement of the propane storage, proper size and number of tanks based on a project site plan, and required total maximum BTU load measured in British thermal units. One tank can be sized to serve all of the building's gas energy needs, or multiple smaller tanks can be manifolded together or placed in separate locations throughout a project wherever gas service is needed. Propane distribution systems are designed to be similar to natural gas systems. Underground gas mains deliver the propane to individual service points on a building. Outside gas piping is buried underground according to locally applied codes and standards developed by the propane industry and by the National Fire Protection Association. NFPA 58, the standard for storage and handling of liquefied petroleum gases, is the main source for tank and underground gas line installations. And NFPA 54, the National Fuel Gas Code, governs inside gas piping installations. Commercial construction professionals should be aware of two new types of products available for exterior and interior gas piping: plastic underground pipe and corrugated stainless steel tubing, CSST. Plastic underground pipe can be used for exterior underground gas piping, such as a propane storage site to the building or a network of piping to metered points of a building or a complex. CSST is used inside residential and commercial buildings instead of or in addition to black iron pipe and other gas piping options like electric wire. Installers can string this tubing throughout a structure and make interior gas line installations quicker and easier for the contractor. There are several optional components that enhance reliability and performance. To avoid on-site inspections and ensure uninterrupted propane service, propane suppliers typically use telemetry units to record and transmit the volume and pressure of service tanks. These smart monitoring devices allow propane companies to track their customers' tank levels and average usage rates remotely to better schedule propane deliveries. Some of today's advanced monitoring systems also integrate with building management systems and allow owners or facility managers to track their propane usage also. Propane metering is ideal for multifamily or multi-tenant projects that draws from the same propane tank. Just as with electric or natural gas service, propane companies can install individual unit meters and bill tenants for the propane they use each month. Instead of owners needing to devise a way to divvy up the cost of unequal use among the tenants or simply attempting to recoup the cost with higher rent, meters provide a hassle-free way to accurately bill individual tenants. Vaporizers increase the performance capacity of a propane system without the need for larger volume propane storage tanks. A vaporizer is fundamentally a boiler that uses heat to aid the natural vaporization process of propane from liquid to a gas. It increases the BTU delivery capacity of the propane storage system without increasing the size or number of propane storage tanks. Vaporizers are critical when storage space is limited on the project site. Propane has long been recognized as an environmentally friendly form of energy. It was approved by the Environmental Protection Agency as a clean alternative fuel in the 1990 Clean Air Act and the National Energy Policy Act of 1992. It's non-toxic, insoluble in water, and poses minimal risk to groundwater and soil. Since it's released as a gas, propane doesn't spill, pool, or leave a residue. Propane vapor in the atmosphere naturally oxidizes in the presence of sunlight or is knocked down by precipitation. For this reason, propane is exempt from EPA's underground storage restrictions placed on heating oil. The propane industry has also found ways to to minimize landfill use. Today, 70% of most storage tanks are made with recycled steel, and 85% of most fittings are made from recycled brass. When a tank's useful life, estimated to be decades in most cases, is over, 100% of the tank and fittings is recyclable. Propane has one of the lightest carbon footprints of any fossil fuel on Earth. It reduces CO2 emissions by 50% compared with electricity. This dramatic emissions reduction is due partly, in fact, to that over half of U.S. electricity is generated by CO2 emitting coal-fired and oil-fired power plants. Propane also provides major emissions benefits compared with heating oil. When natural gas generates slightly fewer CO2 emissions per BTU than propane, it's chemically stable when released into the air unburned, and produces a global warming effect 25 times that of CO2. This means that 1 pound of unburned natural gas produces the same effect on climate change as 25 pounds of carbon dioxide. Propane, on the other hand, naturally oxidizes and is not effective in climate change. While electricity prices on the rise across the United States, many building owners and construction professionals are turning to renewable energy sources to generate heating and electricity. Because propane has low greenhouse gas emissions and can be easily stored on site, it's ideal for enhancing renewable energy systems. When properly designed, propane-enhanced renewable energy systems operate with little, if any, intervention by building owners and managers. Propane is a high-performance energy source which enables architects and builders to meet or exceed increasingly stringent energy standards, along with above-code efficiency programs and sustainability programs that bring market recognition. Several key standards and programs set the stage for commercial buildings. LEED, ASHRAE 90.1, the International Green Construction Code, and ENERGY STAR being the most prominent ones. LEED, which stands for Leadership in Energy and Environmental Design, is a building certification developed by the U.S. Green Building Council. LEED provides building owners and operators with a framework for earning credits by identifying and implementing practical and measurable green building design, construction operations, and maintenance solutions. ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. It's a building technology society that establishes industry standards for building systems, energy efficiency, indoor air quality, refrigeration, and sustainability. ASHRAE standard 90.1 is the energy standard for most commercial buildings, and it's referenced in building codes in many state and local jurisdictions throughout the country. It sets minimum efficiency levels across the major energy use systems, the building envelope, HVAC, service, water heating, power, and lighting. The International Green Construction Code, or IGCC, is the first model code to include sustainability measures for the entire construction project and its site, necessitating energy efficiency requirements from design through occupancy and beyond. The new code addresses conservation of natural resources, materials, energy, water, and indoor environmental quality. Initially published in 2012, jurisdictions in 8 states have already adopted IGCC within building codes applicable to new commercial buildings. Emerging trends suggest more will soon follow. The ENERGY STAR program recognizes high performance in more than a dozen types of commercial buildings, including office buildings, K-12 schools, and retail stores. To earn the ENERGY STAR, commercial buildings must perform in the top 25% of similar buildings nationwide, and their performance must be verified by a licensed professional. ENERGY STAR Portfolio Manager is an online tool to measure and track energy and water consumption, as well as greenhouse gas emissions for commercial buildings. Benchmarking with Portfolio Manager is the first step toward earning ENERGY STAR certification. Benchmarking provides you with a score to compare to similarly used and sized buildings. The documentation can also be used to satisfy LEED for existing home and building requirements. Scoring is done on a 1 to 100 scale, and those buildings with scores of 75 or higher are eligible for ENERGY STAR certification. High-performance propane systems for applications like heating and water heating can help gain ENERGY STAR recognition in both new construction or retrofits. To learn more about building certification under ENERGY STAR, visit energystar.gov and search under Buildings and Plants. ENERGY STAR products can also make a big impact on the energy efficiency, comfort, and environmental performance of a building. A wide range of ENERGY STAR equipment and appliances can be used in commercial buildings, including residentially sized and rated systems and equipment designed and labeled for the commercial market. This chart shows some of the savings you can expect when using ENERGY STAR equipment compared to standard or non-qualified equipment. Savings range from 6% for some boilers to upwards of 40% for ENERGY STAR dishwashers, which can combine with ENERGY STAR labeled water heaters for even greater savings. Go to energystar.gov to learn more about specific equipment that qualifies for ENERGY STAR ratings. You have completed this course. Thanks for your time and your attention.